Yo, 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 what's up? Good morning, good morning. So, before we continue with the shit show from yesterday, I want to double check one thing. Because I have a theory that we should be able to simplify this quite a lot, even though including all of our weird constraints we have on the terrain. It pretty much comes from the fact that I haven't really done us any favors by letting this test terrain being so small as it is. So we're just gonna draw some stuff and hopefully we will see that we can handle this moving interpolation in a much better way than the current approach. I really hope this is true. Because yesterday, like when we get into the details and we sit by point, try to figure out different states for different points, if there are seams and whatnot, it just tells me that we might be moving in the wrong direction. So I want to see if that is the case. 3264. Let's go with 128. Yeah. Okay, so basically what I'm drawing here is we just have a grid here. We're gonna go with each cell is one subquad in our terrain. So this is quite a big terrain with, I don't know how many, but around 11 subquads on the height at least. And then if we take circle maybe and let's move this one to its own. And then we do we can do like this maybe. We have 128. Yeah, let's go with this. Because the straightforward answer, so like when you have the default tessellation, what you want to do is you just measure the radius to the camera pretty much and you tessellate based on that. We have some constraints that we never want two neighboring subquads to have the diff in tessellation should never be more than 1 or 2 to the power of 1. So you should only be able to go like 2 to the power of x goes to 2 to the power of x minus 1 or 2 to the power of x plus 1. So that's one thing we want to make sure. Like, I'm wondering if we make the radius, if the step radius size be big enough, so at least bigger than the diagonal of one subquad, if that constraint holds, if it's still true, right? And it should be true. So we can take, if we take all of the points, we make this step size be the length of a diagonal of a subquad. And then this is tessellated the most. Right, actually, this is tessellated 2 to the power of x and fully interpolated. This is subdivided 2 to the power of x, but here we have... we interpolate the heights. This 2 to the power of x minus 1. What would happen with this one? It would be... I think we should be able to do it like this. So this one would be tessellated 2 to the power of x, because this point is within this one, but we would have no interpolation here, full interpolation here. We could never have a case where, so if we have a subquad, one of the 4 points has to be the closest point of that subquad to the camera. Yeah, we don't have any weird shapes like this. I think we might be able to simplify it like this, although we're still gonna have to, yeah, we're gonna go with the old finding an edge, because we need to add some extra topology to get rid of the rasterization problem, you know. But apart from that, something like this should work. So how would the fading look for this one? Here's the problem then, I guess. As long as each of these steps is long enough, because we can get something like this. So right now this subquad is tessellated 2 to the power of x, and when we get to about here, it's subdivided 2 to the power of x minus 1. But here we have started interpolating the points, so that's wrong. So as long as we have each radius step be same length as one of these, we should be fine. Because then when we get to this one, all of this one is covered by this one. It should be fine. Definitely want to go with a solution like this instead. So we can only support a minimum amount of like the terrain needs to be a certain size for this to actually work as it's supposed to. But I'm fine with that constraint as long as we don't have to go deep into per point flags and stuff like this. So whatever we did yesterday. This is definitely the most straightforward way to do it. Although I'm still wondering our extra edge points. So if we're at this one is subdivided x 2 to the power of x 2, or actually if we keep it like this, 2 to the power of x 2 to the power of x minus 1, but mostly fully interpolated. So we have some extra weird points here that should be now we're gonna interpolate it based on this, so it should work. I don't see why not. Extra points. Yo, what's up, Devioli? Been forever since I checked in. Yeah, long time no see. And thank you for all the kind words. I appreciate it. I appreciate it. It keeps me going, you know. It's been quite a tough period here lately. The work has been extra complicated. So all the nice words are very much appreciated. But I have this feeling that we're just about to crack this and then we can move on to some fun stuff again. Or funner stuff. I would like to take the chance to mention that I finally solved the issue of model bloat of my monster collecting game, and now I finally feel back the motivation creeping in to get things done. Nice, that's a lovely feeling. How did you get the model bloat under control? I'm a little bit worried about the extra points we add here. But I think we can solve it. Can we? Yeah, I think we're gonna go with this solution. So what I'm gonna do first is I'm actually gonna do a partial. I'm gonna commit a partial solution here because I want to keep whatever we did yesterday if we have to fall back to it. Hopefully we don't need to. So let me just commit this real quick. And then we're gonna try this new solution, and I'm feeling optimistic about this one. Definitely. So it's pretty much the usual. It's nothing special about this solution. This is the solution I would we have gone with in our previous Tessellation solution. It's just that we have to add some constraints to it to make it work with the other constraints we have added to the actual mesh. We have environment shaders, right? Terrain, tessellation, test shader. Okay, now okay, now this solution should be added to the repository, so we can just move back to it if this new solution doesn't work. Okay, great. Yoli, I don't want it to spoil too much till I have implemented and can show it off how it works, but basically I decided to only have one shape of monsters, so I only need to fully rig one model while adding only specific parts of the monster as collectible. Oh yeah, so pretty much like a modular solution to it. I like that solution. Okay, so what we want to do here is I'm just gonna move the here. Seam we want to keep. Let's see, we can start with figuring this one out. I'm gonna remove T. We have seam here, we're gonna keep it, but we're gonna make it into a float. And for this one I want to do this 3, and I want to have float 2 UV tessellation. I want to send this one in. We're gonna see if we can make some or use it for some fun stuff. I hope it works out. Me too, me too. It's always fun to talk about the ideas one have with someone who develops a similar but completely different concept. I agree, I agree. I've also been pondering the same problem, with... I mean, that's what you get when you do a creature collecting type of game. So the first problem is how many different creatures do I want? And for each of these creatures, you're gonna have to have animations for every interaction. So let's say that we're halfway through developing the game. We have 20 different creatures. And then we get to a point where we say, oh, the creatures should be able to carry stuff. That means that you need to add 20 different carry animations that can be widely different for the 20 different monster models. And I mean, 20 different carry animations for a solo developer, that's weeks of work if you want to get it looking nice. I haven't really, like, apart from concept, like my creatures only exist in concept form right now, but my idea is to do do both solutions pretty much. We're gonna have different models, but we're also gonna have like a modular solution. So the most straightforward one is color, of course. You can make creatures look, I know, it's hard to sell for gamers these days, but different colors can actually do quite a lot. It's not really different monsters, but yeah. And then with modular parts, like just having a creature with way different horns, for instance. Yeah. And we're gonna see how it works out, hopefully later this year. I really hope to solve the issue described with procedural animations. Oh yeah, if you go fully procedural animation, yeah. Yeah, it's a very interesting problem. I'm pretty sure I will paint myself into the same corner. End up with too many different creature models. I will see when we get there. Okay, so we do seem like this. Did I screw something up here, by the way? Do we need seam here? No, we have seam like this here. Well, when I started on this project, I was thinking a lot about the modeling rigging animation work that Blizzard did to World of Warcraft. If you start to look at it, you will realize they only have like 15 rigs. And usually only notice when you think about it. Having 24 in this seems like a massive workload. Yeah, definitely, like if you have like all humanoids can usually share the same rig, but a bit rescaled, I reckon. And you can get away with a lot there. So you can probably have one. I'm gonna have to do some workarounds, but like so instead of thinking about it like each creature having its own unique rig, you can do creature type, for instance. So you have creatures with 4 legs, they have 1 rig. Humanoid creatures have 1 rig. And yeah. Yoli, but you're damn clever. Thank you, appreciate it. Sometimes. Yeah, I have no doubt we will figure it out. It's just how many corners we're gonna have to get out of eventually. Okay, so there's no way around this variable right here, the seam, because this one tells us if a edge needs to have some extra geometry to make the seam work, right? For 4 legs you need 2 rigs or at least 2 animation sets. A bear is noticeably different than a deer. Made the mistakes in my university time. Yeah, okay. Yeah, I'm thinking with some clever bone scaling, maybe. That's dangerous. I'm gonna take your word for it. Definitely 2 different animation sets. I think you could, maybe you can split it up like, I will see. I'm gonna have to do a lot of thinking and tinkering with it. But it's definitely like how they use their 4 legs. So if you have a deer, they 100% depend on all 4 legs for standing most of the time, right? Unless they are climbing, while a bear can actually just do with 2 legs. It's extremely interesting. Like, animation is also something I'm gonna have to work a lot on. I'm not great at animating stuff, so it's gonna be an adventure to say the least. Okay, so what we send down here is seam and seam to figure out if a vertex needs some additional geometry spawned to make the seams work. We also send down the UV, so this is the original mesh UV. We use this for terrain data and stuff like that. And then I'm sending down UV tessellation here. And we're gonna do the classical hack of figuring out if a point, or how much a point needs to be interpolated based on its UV tessellation. So UV tessellation, it's pretty much this one. So this is the original UVs for the full quad. And then when we do tessellation, each sub-quad gets its UV tessellation here. And we're going to use this one. So each point has this one, and we can figure out how much a point is tessellated based on that. And we can also figure out how much we want to interpolate the height of it based on that. So we want to send this one down through the, not the full pipeline, but when we introduce it in the domain shader, we want to send it down to the geometry shader and fragment shader maybe. Also, a deer would attack more in a flutter. A bear would bash you. Oh yeah, 100%, 100%. Hopefully, like, it's probably a good idea to... So when you have your concept art of your creature in place, it's probably a very good idea to fully define it in text as well, right? Like, how does it move? How does it pick up stuff? Can it use its front legs? How does it jump? Like, define all of those things, and then hopefully when you have a set of creatures, you can hopefully put them into separate groups, and each group can have its own rig. But yeah, you're gonna have to do a lot of rework pretty much. Okay, so let's see here. This one we don't care about anymore. This one we do like this. The diff here, I don't think we care about this one right here. I can delete it. I don't need to feel bad about deleting it because we can roll back to it eventually. Yeah, monsters, animations, personality, and so on. Ah, definitely. Definitely. Okay, so that's it for this one. For the domain shader, we handle seam the same way, like this. We delete these. We don't need these anymore. And then we take this one and set it here. We don't have T anymore. But then we want to send down, so we're going to do output.uv tessellation is equal to UV tessellation. So UV tessellation we don't have to calculate ourselves. We actually get that as an argument to the domain shader, so that is good. We don't care about T here. I'm gonna remove this. For now, I'm just gonna set this one to 0.0. And yo, what's up, Ling Ling? Yoli, okay, I need to start my day job now. Good luck on your day job. It was a pleasure talking to you again. Same, likewise, likewise. And I wish you the best of luck with Tessellation. Thank you, I'm gonna need it. Hopefully better news on both sides, yes indeed. I'm very optimistic about this simplified way of doing it. I think we can manage to pull it off today. But I've said that before. So here, create point from. I don't think we need UV tessellation after this one. So for now, I'm just gonna do position interpolated. We're gonna do float to UV tessellation is equal to. We're probably gonna need it for the height here, but UV tessellation is equal to lerp between p1.uv tessellation, p2.uv tessellation, and 0.5, so in the middle of it. And then I just want to see if I have missed something here. We did a lot of weird stuff yesterday. I think it's okay. Let's see if it compile. We have a little bit of a Y here going on. Yes, seam. We want to skip. Seam. We want to keep. Seam. Seam. Oh yeah, we added X here, which I want to get rid of. Could just do a find and replace, actually. But let's do it this way. Something like that. I have a class in an hour where some fellow students are presenting some papers. Love that. But I also have another mandatory presentation attendance of 2 hours after it, and 4 hours plus is a little much, so I'm contemplating skipping the first one. I would go, like, yeah, sometimes when you had student presentations, some people didn't take it that seriously, and then it just felt like a waste of time. But it's definitely fun to listen to the ones who do. I'm just gonna return black here for now. So let's just do return 0. Okay, and then we're gonna try the layering system. What I want to do then is I want to make this one way bigger than it initially is. So right now we go with a 4x4 subquad, and it's 10x10 meters. Let's bring that up to, I don't know, let's bring it up a notch at least. So I'm thinking let's do it. Have I hard coded the size for this one? Let's fix that first of all. Subdivision, we're gonna do private float. Let's just do it as size. I think it's we have it here as well. So let's take this one, this one, this one, change it to size. Let's do it like this, and then let's remove that one. Okay, so now we have size as well. But yeah, also like sitting and listening to something more than 4 hours. Pretty damn tired after that, I do agree. And if none of them takes it seriously, yeah, then it's definitely gonna feel like a waste of time. Let's go with 100 here, and then we have 2 to the power of whatever we have here. So we have 4, 8, 16. 16 might be all right. I don't know if we generate that much more vertices. 20 seconds of vertices, I don't think so. Okay, there we go. We generate a noise texture as well. Okay, now we have a lot of... We sure as hell have a lot of sub. And then we want to change mesh dimension here is 100. And mesh resolution. Okay, something like this. And then if we pull up, we subdivide it a bit more, 6. Can we play around with this? Hopefully. Lingling, I will probably flip a coin on it. Yeah, let fate decide. I don't like the scale of the noise texture here, but we're gonna go with it. I mean, we can just bring it down like this a bit. Good performance as well. Okay. So the next step here, actually, mesh dimension. I want to sand it down mesh dimension as well. We don't do that currently. So we have mesh dimension, height map size, mesh resolution, height map size, texture size. Oh, we actually do texture size. No, we don't. Let's do material set vector mesh dimension. And here I'm just gonna do size time vector 4.1. Okay, we send that one down. Now we shouldn't need to change that one. Okay, so what I want to do next is no, actually, I want to send down one more thing. Is this GLSL? It's HLSL. It's pretty similar, I would say. Okay, so what I want to send down is we want to send down the diagonal length of one subquad. The thing is, we could easily calculate this one in the shader, but if we calculate it in the shader, depending on where we do it, we're gonna do it for each point or whatnot. It's better to just calculate it once on the CPU and send it down. And we're just gonna do this at when we initialize the terrain, and then it's gonna be static pretty much. So no, like, we want to offload as many calculations as we can from the shader. So pretty much the less dynamic it is, the more we want to offload it. So something static like that is just initialized, or it's just that can be just calculated when we initialize the mesh. It's a no-brainer to do it on the CPU and send it down. Is this CPU work? Wouldn't the GPU be good at it? Like, okay, so what we're gonna do is we're gonna calculate the diagonal length of one subquad. This is something that when we initialize the mesh on the CPU, whatever the size of the subquad is gonna stay the same throughout the game. So this is a thing we just need to calculate once, and then we can just reuse that value. So there's really no need at all to do it on the GPU, because if we do it in like the vertex shader, for instance, then we're gonna do it every frame for every vertex. And I mean, it's just unnecessary, you know. It's also like this. If we have this quad, this full mesh consists of 4 subquads. We just need to calculate it for one subquad, and then we know that each subquad has the same length. So yeah. And I'm gonna use this. So the reason I want to calculate this diagonal length is because when we do this, I want my quads should never be able to be inside. At most, one subquad should only be between 2 stages. So this one right here, for instance, it's between the light green so it's between the tessellate to 2 to the power of x and interpolate. That's the green stage. And it's also in the tessellate 2 to the power of x minus 1 state, but don't interpolate. Right? I never want a quad to be covered by more than 2 stages, because if it is, then we're gonna see this solution break. So tessellate 2 to the power of x, which makes me wonder. Yeah, so green and blue tessellate 2 to the power of x. Green is interpolate the values between, or interpolate the heights between 0 and 1. Purple and blue tessellate 2 to the power of x minus 1. Purple is let the height be what it's supposed to be and interpolate the height in blue. And I want each of these circles to have so the radius step size should be equal to the diagonal of a quad. Right, so we're also gonna add terrain tessellation. Here we're gonna do mesh dimension, mesh resolution, mesh subquad diagonal. I'm gonna put it as a float. Let's start with 0.0. Do we have it here? And then I just want to calculate this and send it down. Best quad. Subdivision. Yeah. Number of subquads, it's not really maybe we can rename that one eventually, but let's see here. We don't need to round here. Is this... am I doing the correct thing here? Yeah, I am. Okay, so material.set float mesh subquad diagonal is equal to so we're gonna do float subquad size. Here we do size divided by number of subquads. And then here we do mathf square root of we do 2 times how subquad size 2. Or we could just do should be enough, right? I think about it correct. try this. And let's rerun it so we get the correct data down to the GPU. And then we're gonna do... First of all, I'm just gonna start tessellating. I wonder, so we're gonna do it when we calculate the tessellation amount for one quad. So like for one subquad, the tessellation amount for each edge should be the same. So when we compare, when we try to get seams, we're probably gonna do a lot of distance calculations, but it might be okay. So pretty much what I'm getting at is for each subquad here, for this one, for instance, when we calculate how much to tessellate this one, we take this point, this point, this point, and this point. We calculate which one of those four is the closest one to this one. And then we take that one and we tessellate it according to that. But then we also want to check edges against this one, this one, this one, and this one. So then we want to take all of... So that's gonna... We're gonna check for... What is it? 20 points. 20 points per subquad is what we're gonna double check. It's a lot... But maybe it's okay. Yeah, it should be okay. Mesh subquad diagonal length 8 times 8. Is that roughly what we want? So we have 100 divided by 16 to the power of 2. Times 2, and then square root of this. Yeah. Yo, what's up, Catboy King? Okay, this is nice. So now I want to calculate the tessellation amount based on this, the new way we do it, and then we are gonna have to analyze this real good, and we're gonna have to double check if... So like we're probably gonna bring this one down a bit, and then we're gonna double check so that we always only have... So we should never go tessellation 2 to the power of x to tessellation 2 to the power of x minus 2. So always just one step. We don't care about diagonal, so this is okay. So this one is 2 to the power of x minus 1. This is 2 to the power of x minus 3. This is okay. We don't care about those seams. Only this way, okay? So we're gonna have to re-implement our calculate tessellation exponent. We want to bring the height into this as well, and I think, unless I'm missing something, it should be okay. So instead of checking spheres like this, we're actually instead of checking circles like this, we're actually checking spheres. But since our radius step is the diagonal of a quad, I'm trying to convert this to 3D in my head. and see if we can have a case where one quad is covered by 3 different stages. I don't think so. Okay, so let's get this. Calculate tessellation exponent. So instead we're gonna need to send in... I don't want to do this by center position anymore, or makes me wonder. If we just check the center position... No. It's gonna be messy then, because in that case we might have points that are closer to the camera that gets their height interpolated in a little bit of a different way. It's gonna fuck it up. We always want like the closest point in the subquad, always. Which actually, take a look at this. So I did one assumption previously that was wrong. Let's do image. Snap to grid false. Look at this. So here we have a case where this point is in the purple, this point is in the purple, but this, we have a few points here that are actually inside the green. So we're gonna have to do... We're probably gonna have to add a method to our util math. So we're gonna do some math stuff, not looking forward to that, or some complicated math stuff. So I would love to be able to calculate. So if we have a quad made out of 4 points. So pretty much what we want to calculate is get point on quad closest to another point. Beautiful. Unity as well. This is exactly what we want to do. Yeah. Ooh, I don't know. Actually, if we have something like this as well, do we get... Look at this. But if these were... If these were the diagonal size, we wouldn't... Or actually would... No, we wouldn't. Okay. So what do we have? Closest point to rectangle face. Face, closest distance. for loop. So take distance to each point. Draw a sphere around it. Okay. What we can do is, if we just think about it ourselves, we could fuck, is that true? Yeah, it should be. So if we have these 4 points, we calculate the closest point, or yeah, we pretty much order them as distance to camera. So if we order these 4 points based on distance to camera, and then we take the 2 closest points, then we get this one and this one. Then we have the line that is closest, and then we can just check get closest point of this line to that point. So that is a 4-point comparison, and then if I remember correctly, we actually calculated that previously, didn't we? Didn't we? Closest point online, here we go. In fact, we had this one implemented previously. Let's implement both of these and keep them around, I would say. But I wonder, I probably don't want to... So here we have util math. I think I'm gonna add util math geometry. Aunque busques el significado del amor en Google, tú dime que me quieres, pero no lo jures. Noise, I definitely want in its own. It's all about... I don't want these utility files to grow too big. I want to keep the shader sizes small. So for instance, if we introduce this geometry stuff, like 90% of the shader files that include this one doesn't need those methods. So yeah, let's do... We're gonna move some over there eventually. I want to create a GitHub issue for this as well, so one sec. These are 2 functions that I think are pretty good to have. Create, or actually we're going to implement util math geometry HLSL. Pretty optimistic about this solution actually. Let's see here then, and then we'll go to issues. do add implement what do we want to call these methods? Nearest point online. Nearest point online. Implement nearest point on quad. And move relative related functions from util math to util math geometry. Something like that. Okay, beautiful. Let's do that real quick. Yeah. Okay, so might not wanna... Let's wait with... Ooh, pi is... let's leave that one. I don't even know if we need to implement it ourselves. We might get it from this one, but yeah. Util math geometry. Float 3 nearest point on line. Float 3 line P1. Float 3 line P2. P. Float 3 This one works. This needs to be, so let's do float 3 line direction. Need to be, I want to be explicit. And then I wonder, we just do it from the first point. Okay, that's okay. So let's do line direction. Is that line E2 minus line E1? something like that, and then we do line direction normalize, but we do it like yo, what's up PG King? Good morning, good morning. Var point line point. Yeah, so what we do here is float 3, let's call it V as well. So here we do P, and here we do line P1. Direction, so just use float. Dot between V and line direction. And then we do line point 1 plus line direction times D. And that should be it, I think. PG King, how did the Tessellation go yesterday? It was sort of a shit show. I think we were on the path of completing it, but yesterday after the stream I spent some time thinking about the problem and decided to go in a little bit of a different direction once again, which we're currently exploring. I'm optimistic about this one, as I've been before. It's gonna be... This is a little bit more of the classical solution you would do, you would go with this problem. But I think I've found a way to add some constraints to it that makes it work for our terrain as well. So we're gonna find out today. Oh, sorry about that. I muted. I don't know, was I muted when I answered your question, PG King, or not? Nearest point online, I'm gonna go with a solution in nearest point on quad where we utilize nearest point online. I don't know if that's the best way to do it, but it will work. So what we're gonna do here is we're gonna do float, or shortest distance. And we can probably do this in a smart way where we if we choose the closest point so like first I was thinking of just keeping track of one, and then we like push it down because we need 2 points here. But if the first point we check is the closest one, we're gonna have a problem. So we're gonna have to do let's do it like this. Shortest distance is equal to. Did you hear a shit show you say? Yeah, I was. The solution we were pursuing led us down a path where we were individually per vertex in our full terrain trying to build up like a library of flags pretty much. So is this point like we were just adding a lot of different data for each point, and then I worked us into sort of a branch type solution, which just made me think that there has to be a cleaner way to do this, which is what we're pursuing right now. Okay, so we can do it like this: float quad p1, or distance p1 is equal to distance between quad p1 and p, and then we do float distance p2 equal to distance quad p2 p, and then we do float, or if float shortest distance float 3 closest point, float 3 next closest point. If distance p1 is bigger than distance p2, else. Then we do shortest distance is equal to distance p2. And closest point is equal to quad p2. And next closest point is equal to quad p1. PG King, I thought it was something new today. In a perfect world, it would be. But yeah, we're still on Tessellation. E1. Hopefully not after today or tomorrow. But we'll see. We'll see. Okay, something like this. And then this for loop chain feels do we even want to do a for loop here? Why not? Nah, we don't want to do a for loop. Lillian decided to skip the first set of presentations, no mandatory attendance mentioned anywhere, so we should be good. Ah, nice. Hopefully you won't miss anything too interesting. Galaxy, what's up? Hey, whatever you're doing, you should rewrite in PHP. Yeah. Fuck, am I screwing up here? Yes. this one might be closer than this. Lingling, worst case I miss a decent presentation, but I have to study the paper for my exam anyhow. Yeah, shouldn't feel too bad about it. Let's do this. Can we just do... compare these two... Closest line. See what some smart people have done here. Now we're pretty much gonna have to compare. But I wonder if nearest point. Jesus, this looks cool. Initial premature. I don't even know what this is. I don't want to do some sorting stuff here. Lingling also we all know real game programmers code in Haskell. Okay, I have a little bit of experience with Haskell. Not that much. It definitely was a different way of thinking, that's for sure. We're probably gonna have to do float, distance, P3, distance quad, P3P, float, distance. I appreciate that Haskell joke, I do. Okay, so we just calculate all the 4 distances and then we have to figure out still wonder if there's a easier way to do this. Actually, now when I'm thinking about it, we're fucked. If we do it like this, as I initially thought, it works for 2D, I suppose, but what if we have... what if we have... and we have the camera located within the quad, then it's no longer a point on this one, it's actually within it. Okay. I have a basic grasp of Haskell, but I don't see how we build big programs in it. Yeah, I'm pretty much at the same point. Okay, so let's see what the mathematicians say. Don't we have... I would have hoped for... Yu Xiang, what's up? What's up? Good day, good day. I would have hoped for... math stack exchange would be nice. We could also do... if we assume that this quad is in the same plane, we could do project and then we could do some inverse bilinear interpolation, maybe. Get point on plane closest to point. Ah, here we go. How do you know all these concepts though? Experience, I would say. Yeah, PG King, now we're down in it. In the gruff. Okay, so if we calculate the normal... yeah, we should be able to assume that each plane or each quad lies in the plane. Yeah, definitely. I think we can simplify this quite a bit as well. We know that our normal is 0, 1, 0. Okay, so we have the normal vector. What do they do here? So norm, or the point plus... some constant, the normal is equal to something. But this point has to satisfy this plane's equation. The problem when then we can do some inverse lerp, I think. Fuck, can we? So what we would do here in this case is pretty much, let's try, if I try and paint in 3D, so this is a plane that is rotated a bit or whatnot. So this is the plane, or it continues forever basically. And then we have a point up here, down to the plane. What can I do? We have a point here which is above the plane. If we find the closest point on the plane to this point, we're basically doing it's some sort of projection down to the plane. So we might find this point in this case, but then we might have, so we have this quad here, and then we want to find the closest point of this quad to this point. I wonder if we can just inverse lerp. So can we do that? I don't know. But this we have calculated as well previously. Yo, what's up, Spires? Thank you for the raid, appreciate it. You too. So if we find the closest, first we find the closest point on the plane, and then we find the closest point to our plane, or our quad to that point. And that should be it. But I'm wondering, if we just do, I was thinking here that we could take the X and the Z and just truncate it to within this one, but I think that we can't really do that. Okay, we're probably gonna need to do this. This, but then I also want to do point inside quad on plane to another point. I don't know. What's up, Quaz? We're making a little cozy creature collecting game. But much like Tamagotchi, Viva Pinata, Chow Garden. More specifically, for the past weeks, we have been fighting Tessellation to get our terrain and snow and water and whatnot to work perfectly. So that's pretty much what we're doing. What do we have here? That's not what we want. Isn't this exactly the one we... with the same solution. I want to double check one thing. We have you till... If I remember correctly, when we did reflection... Point on a plane... Is point within screen bounds? Did we just do it like this? Get point with offset, get ray point, get ray depth, inverse lerp. Oh, cool. Can I get a sneak peek? Not right now, unfortunately. You can probably check out some videos on my YouTube. We're currently working... like we have scaled back most of the scene and only work with a simple plane right now. So this is pretty much what we're looking at. This is not what we want to do. What I'm afraid of is... Okay, if we take this one and we paint... This is a perfect question for like ChatGPT as well, but whatever. Can double check it soon. If we have a quad like this, so this, we're looking in 2D right now, and we have a projected point here. So this point is in the quad plane. If we were to... Brain point to what? Yeah, I mean, every creature collector out there is always going to be compared to Pokemon. We're not going to have any fighting. Like, my perfect comparison is probably Chow Garden in Sonic Adventure 2, I think. I forget. Let's do this. We're gonna go to ChatGPT. Let's see what it says. Find point on, or let's be nice. How to find point on quad closest to another point. Oh, let's see. In order. Do we have it in order? Yes, we probably do. We have V0, V1. We're gonna have to fix the order a bit, maybe. Depends. Calculate perpendicular distances. The closest point on the quad literal to... Oh, we might want to do it in 3D as well. Like, yeah... We lie on one of the edges of the quad. I don't know. Am I misunderstanding something? Is this even true? What if P is within the quad? Reach edge. But okay, but doing this assumption, so then we just care about edges. But yeah, if we did this assumption as well, then we could just take create a line, create a line, create a line, create a line, and then we just use this one, and then we check distance pretty much. How to find a point on quad closest to another point. The closest point on the quad literal to point P will lie on one of the edges of the quad. I don't... Okay, so now we assume that the quad is not doesn't have to be on the plane, right? You then check if the projected point lies inside the triangle or on its edges. But what the fuck? One sec. If the projected point lies inside the triangle, then it's the closest point on the triangle, yes. If not, the closest point will be one of the triangle's vertices. Couldn't it be on the edge as well? I think I'm misunderstanding this shit. So if we have this point, it doesn't lie within then the closest point is this one. But if we project it... Okay, so this is the exact same thing we were gonna do with this one. So we project the point. We project the point down to the plane, and then we want to check if the point is inside the quad or if it's outside. I just don't buy... second guessing myself here a lot, but is this actually true? I might not have phrased the question that good, but I don't think... this is true. Okay, let's assume we already did this. Use the cross product, check if the point lies inside. Fucking hell, I didn't anticipate this to be... Yeah, this feels a bit... Oh! Do. One sec, I'm starting to think... I'm starting to think that our first solution might work, might be the best one. One sec. What if we... might be good enough for what we need it for. What if we... Or actually, let's do it like this. Find the distance between point and quad in 3D. Yes, thank you. This... check if the point lies on the same plane as the... Yes, we compute two vectors. I think this is A, B, C, D. Yeah, I think this is the bitangent, the tangent and the binormal, or whatever you call them. And then we calculate the normal of it. We already have the normal though, so we can take some shortcuts here, I think. Yeah. Okay, beautiful. Yeah, okay, we can check this. So, okay, fuck yeah, I think we're gonna do this and hope it works. It looks good so far. This projection is sick though. One sec. Okay, yeah. Project P-Proj onto each edge of the... And this is what we thought about doing. So pretty much it's this. We wanna project the point onto the plane. We want to project it onto the plane if... Let's see. Yeah, I think we can just do it like this. So we take the point, we project it onto the same plane as the quad, which is just a simple plane with a normal 0, 1, 0. If the projected point and this point is the same, then we are on the plane, so the closest point is this point, and we have a distance of 0. Otherwise, so that means that if we project it on the plane, we end up somewhere outside of this. So what we do then is we create 4 lines, and then for each of this line we check closest point to this point. So for each line, okay, first of all, for each line we calculate the closest point to that point, and we get the distance as well. So what is it here? It's roughly this one. I don't know, maybe this one. So then we have these 4 points, and then we just check these 4 points. And we take the shortest one, and that's the point we have. Or that's the closest point. Should be like this, I think. We can simplify the calculations quite a bit in our case, because we know the normal. That might not always be the case, so we're going to implement a nearest point on quad where we do some additional calculations, calculating the normal and stuff like that. I'm always going to assume, though, that the quad lies in a plane. I don't really care, maybe in the future, but like I don't want to take into account if we had have a quad like this. I don't know, it's 3D. I'm doing my best here. So we're just always gonna assume that the 4 points making up our quad lies in the same plane. So then we're gonna calculate one where we calculate the normal, and then we're gonna do one method where we send in the normal of the plane. So if we already have the normal, yeah, then it's also very important that when we send in the points, we make it so that this is the order always. So point 1, 2, 3, 4, I reckon. So it's projecting the point that is the hardest step, I would say. So first of all, it's just trying to calculate a normal. So we're gonna do like, I wonder, it lies in the same plane. Okay, so let's do it like this. Float 3. I would love to... I would love to be able to return the distance here as well. So not only the point, but also the distance. Or actually, we don't have distance here, don't. Ah, fuck it. Let's do it like this. Okay, so nearest point on quad, and then I want to implement a nearest point on quad. With normal. Float 3, quad P1, P2. E. Okay, like this. So first of all here, we're gonna calculate the normal. So that should be, let's do float 3 tangent quad P2 minus quad P1. Float 3 by normal quad P3 minus quad P2. Actually, now when I think about it, we want to calculate this one and this one. So shouldn't this be 4 if we do it like this? Maybe it doesn't matter. Yes, and we do float 3 normal is equal to normalize cross tangent by normal. And then we do return nearest point on quad with normal. Quad P1, P2, P3, P4, normal P. Okay, so on to the next step. Lies on the same plane by computing E minus A. So if dot normal, what is it, A, so we do P minus quad P1, if this is equal to 0.0, return P. Oh, no, 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 no. If it's not equal to do something, we're gonna float P projected or plane P. Plane P is equal to P. Else, okay, now we want to project it. Get on. Plane P is equal to P minus normal, that's dot normal, is it, yeah, P minus quad P1 divided by dot normal. That's all of this, and I want to multiply it with normal. Is that it? Times normal. Just gonna assume this is correct. Right. Okay, and then we can start doing project point onto an edge. Yeah. Okay, so now I just want to calculate, I want to do this 4 times. So for P1, P2, P2, P3, P3, P4, and P4 and P1. And then we're gonna have to compare all of those. That's about it. So let's do float 3 edge points is equal to always forget how we do this. Let's just double check the syntax. And we have it here. Don't water should have it here, I hope. Actually, let's go snow. Rain procedural snow. Here we should have it. Okay, let's see if it complains about this one. Edge points. Nearest point on line. Pod P1. Pod P2. Plane P. And then we just do this 4 times. 2, P3, P4, P3, P4, P1. float closest point or closest P is equal to edge points 0, float shortest distance then we do distance is equal to edge points I plane P if distance is less than shortest distance, then we do closest P is equal to edge points I and shortest distance is equal to distance. And after this we do return closest P. That's about it, I wonder. Okay, we check if the point is on the plane. If it is, that's our plane point. Otherwise, we project it down on the plane. So then we have a projected point on the plane. And then we create 4 edges. We're missing one thing. If the point is within the quad. Did we have it here? Project the projected point onto the edges and determine if the projection lies inside the edge. If we project it on the edge, it should lie inside the edge, right? If the closest point is one of the edges, if not, the closest point is one of the edge's endpoints. If we project a point onto a line, it should always lie on the line, question mark. Okay. Anyway, like what we do here, what this does is that we find this works for points. This works for all the points outside of the quad. If it's inside the quad, we can probably check. Yeah, we can do a second check here. We can do... But fuck, that would suck. We could do... If we calculate the direction of each line, which we actually do, here, then we can check so that if the point lies on the same side for each of them, then we know it's inside the quad. But like that would be if we do point, if we calculate the direction for these edges and the point is always on the right side for all of them, then we know that the point is inside of the quad. Then we know that the projected point is the closest point on the quad. So if we have this one, for instance, for this one it's on the left side, on this one it's the right side, right side, right side. But yeah, it's the left of this one, so it's outside. I don't know. Do we want to, like, we do calculate the direction. So it wouldn't really be, we wouldn't add too many calculations, but we would have to restructure this a tiny bit, right? Because we need to get more information out from the method. Or actually, that's wrong, that should be P. And actually that should be plain P. I'm wondering if Are we seriously gonna need direction? Does it mention it here? Okay. Because we calculate AB and AP, and then we do cross product between those two. Fuck, do we do? ABAP. Okay, let's. So we have point and a point. This is the edge, and then we have this point right here. We calculate AB, this one, AP, this one, Then we do cross product between them. So cross product, AB cross AP minus yes, we calculate these two, then we calculate a normal. And then we check the direction of the normal. Can we do that? So, depending on if the normal is up or down. So we could probably do, can we do, so this one is called AP, AB. We can probably do dot sine dot between AP, AB, normal. Right? Like, how do I want to structure this in code? Are we going to introduce a custom struct that is line? And maybe. What do we want for a line? We want start point, end point. Then again... Or am I just overthinking stuff? We might want to add this as a to-do. I'm thinking... if... Okay, so pretty much what we're trying to avoid is a case where we get the wrong tessellation because the camera is inside the quad. Our first check is radius of the diagonal here. So yeah, we're always, even if it's here, the closest point is gonna be here. It's inside of the radius. We don't really care about this now. So fuck it. Check if plane P is inside quad. We can probably do it like this. So now when we have these two, when we have this method, let's do the terrain tessellation test. We are gonna send down position 2. Let's calculate this point. So inside of the hull patch constant function, we just do output dot point is equal to nearest point on quad with normal, and then we do we have to make sure that we send it in the correct way, so we want to send it in V0, V1, V3, V2. So patch 0 point position VS, patch 1 position VS, patch 3 position and then we have the normal, right? I'm just gonna do float 3010. And finally we have the point in question, and that is world space camera position. Okay, so we calculate the point here. Output dot point equal to factors dot point, and then we have here output dot point is equal to p1 dot point, and finally in the fragment shader we do return inverse lerp 01. I don't know, 0, actually, yeah, 1 0 distance between input dot point and input dot position VS. I think this is what I want to do. Undeclared identifier nearest point with normal. Yeah. We need to put this one above that one. Oof. Yeah, okay, we have something wrong here. Oh, what is it? Float 3 4. I think we can do it like this, maybe. Unexpected token, float 3 edge points 4. Distance. Oh yeah. Unexpected token point. Oh yeah, we probably can't use point. P E. Index out of bounds. That's not good. Zero, 1, 2. Okay. Do we have? Okay, we have something here. We have this, but that's not very good. Okay. Zero, 1, 3, 2. Normal. World space camera position. Yeah, we never get inside of them, but we're okay with that. Ooh, the question is... Yeah, we might want to get the point inside, actually. Like if we go upwards, yeah, we might. We want to get the closest point inside. Okay, so we're gonna have to calculate that. Even though I wanted to avoid it. Because if we have a nice little plane here, maybe we have the camera. We have the camera here. We do a sphere around it. The point on the edge might be outside the sphere, but the point we're interested in, which is on the quad, might be within the sphere. So if we want to get dynamic tessellation based on height, I don't know. I'm trying to create a generic tessellation solution here for this, so it would be preferable. And then I also wonder... I'm gonna do it like this. When we print this one, or when we render it, I want to render it for all of the subquads. So input P. Why don't we? The distance between this one and this one. Nearest point on quad with normal. Yes, probably. Fuck, is this the correct? Yeah, we probably want to do it here. Why? I would anticipate seeing. I would like to see this. I would like to see a point for each sub quad. So I'm talking like half a sphere here, I would say. The question is why I'm not getting that. We're doing with P. Are we setting? Output P factors P. Output P, P1P. Distance between input P and input position VS. Am I missing? Domain. Oh. Each patch is sent into this one. We calculate it per patch. And edges. World space, camera position. Okay, let's just do return float 4 input.p 1.0. Oh, really? Yes. So each of these subquads should have a individual P. So for this one, it should be located around here, I reckon. So when we render these fragments, they should be inside the radius of 1. So we should render a point here, but I'm missing something. Some tiny little piece. Input P, input position VS. We do set P in these methods, otherwise we should have it from here. So here we set output P. Here we should set output P. Factors P. Factors. Float 3P, text chord 5. It's almost like I'm sending in the result we're seeing, the rendered result. It's almost like we're sending in the same. All of these. Space camera position. That's okay. Okay, what if I do... I want to double check if this one is wrong. So we just do output P, output, or actually no. Patch 0 position yes. Exactly. So that works. That works. This doesn't work. I mean, it works for the closest. Okay. It's like we get... So for this one right here, it's like we get... Let's do... 10 here. Yeah. Okay. But it works in Y, but not in... Or actually it works. Anyway, it's like the closest point on these... I don't know what the fuck is happening here. But yeah, it's like the closest points. So this subquad should have its closest point somewhere on this edge. But it actually has it here. That's weird. Position VS, position VS. Oh, one sec. I might have... Get patch here. We actually want it like this? No, we don't. But it's, let's see here, util math geometry, nearest point on line. Did I screw something up here? Yeah, maybe I did. Yes. Or line point, line direction. We don't constrain this one. Nearest point on line. Ooh. we want to do, so this is the distance, it's between 0 and 1. Line direction. Don't we want to do min 1.0d? Maybe. No. That's something. Oh, no. We want to do. Want to normalize that one. Okay, that's wrong as well. Actually, that's. Yeah. Hate what's happening for these though. This is probably. Yeah, it's not entirely correct. So let's double check this one. I need to be careful here. Line direction. That's not really the direction anymore. Okay, we normalize it. We do calculate this one. And we do dot between this one. Line direction. This one is normalized. We want to limit this one so it's still on our line. We have an endpoint of our line. Dot product, we take our point minus line. We get, and then we do dot product. Don't we have... I'm pretty sure we had this calculated here in a previous version. Let me just double check. Oh, yeah. Ah, beautiful. Line, length, magnitude, line, normalize. We want to clamp this one, but I wonder... Let's do this. Line vector, line length, is it magnitude? Length. Line vector. And upload line direction. Okay, now we have them all. Let's see what we want to do. Length, and then we have normalize. So we still do dot with the line direction, and then we just clamp this one. So D is equal to clamp. X min max. D 0 and line length, right? Nice. Now I would love it if we could get it to work for inside as well. It's a very specific edge case. It's a very specific edge case. And it's a lot of calculations. I mean, if we want to do it, it's 4 cross products and then 1 or 4 comparisons, 3 comparisons maybe, 4 comparisons. We could also... Whoa. No. We should be able to calculate this an old school way. If we just take the center point of the quad and then we check so that the X and Y distance of the projected point is less than whatever the length is, then we should be fine, right? We'll take the center point. and x and y distance to the projected point. But then we're gonna have to calculate, so it's one bilinear interpolation. It's fine. Or we could actually do... I think we're gonna do it like this. Util math geometry. We are gonna... Nearest point on quad with normal and center. Normal, float 3, center point. And then we just do... We have the projected plane here. So we do... So the idea then is down here, we calculate the center. No. So here... No, here. And we calculate the center right about here. We can do it now, right? So nearest point on quad with normal and center. We should be able to do if abs plane P dot X depends on fucking hell. Yeah, it's simple as this if yeah, now I'm working under the assumption that our plane is rotated, so it's just occupying 2 dimensions. Then it's as simple as this, but maybe... I wonder if we can do abs plane EX minus plane P. No. Center dot X. If this one is and we need the length here as well. Can do see, we project it on the plane. and let's take the fuck the center solution. Let's take the jump and do struct line. Something like that. Nearest point on line, we don't need to calculate any of these. We just do that, and then we create line edges, maybe. Create line from points. Something like that. Ling Ling, what's up? Do you assign yourself to-dos in GitHub issues? Yes, I do. Or I try to do. Sometimes I forget, but yeah. That pretty accurately describes my relationship with C as well. Maybe not for the last years though. Okay, so what do we have now? We have create line from points, etc, etc. So here we just create a set of lines. And then we want to do closest P is equal to nearest point on line, edges 0. Closest P plane P. Like this, right? Float 3 new P is equal to nearest point on line. Yeah, actually we need to do this. Edges I, and we need to send in plane P. We need to do the same here. Okay, something like that. Now I think we're back to where we started. Like, let's take a look and see how it looks. Yeah. Redefinition of line. Yeah, because we want one of these. Oh no. Unexpected token line. P. What am I missing? I'm gonna return it as well, but I'm not sure that's it. Yeah, I learned object-oriented programming before I learned C, so it was was quite hard trying to get rid of some of the things object-oriented related stuff when you were doing C later on. What am I missing here? We define it, we return it, we instantiate it like this. Instantiating it the wrong way. I'm pretty sure this is how we do it. Oops. Yeah, okay, I just wanted to double check if we had some naming. The not needing proxy manager observer listener class is needed. It's pretty clean, bare bones. I've actually struggled a bit recently with where I want to go next with my coding. What are you thinking about? What are the possibilities? Or is the problem that you don't? Like, I'm wondering if do you have too many possibilities or none? What the fuck am I missing here? It's struct semicolon main shader output. Unexpected token line, and then we have the same for all of these except for P, which comes later on. We defined this one first. Start and Ling, I really enjoy Java, but Java programs also nibble half your computer resources. C is the opposite, very low resource necessary, but very slow, hard to code. Okay. Between Java and C, I would probably go with Java. But if you introduce C#, I would definitely go with C#. Okay, but this one. Something here is wrong. No, it's not. Is my struct definition wrong? Why would I pick C#? It feels like you get the pros of Java, but not the cons, so to speak. Should be able to struct I'm missing here. Oh, yeah, I know. I hate this error. Point and line and triangle, we can't use those names, so... Let's go with the next best. L. Still have a line here. Okay, we have a few. LLLL. Okay, unexpected token float. Semicolon. Undeclared identifier edge points. Yes, we want to do current distance between new P and then new P here. Okay, beautiful. Now we have the exact same result we had previously, but now when we have them as lines, we can probably check if it's inside. Lingling, but does C# have some great low-level graphics API we can use to make neat drawings? Yes, it does. I'm pretty sure. Although I let Unity do that stuff for me, or I have the Unity layer in between. I don't know, DirectX 12 is hot shit. Okay, that's one step forward. Now I just want to double check if we're inside, and let's see if I have this, if I understand the math behind this. So we have 4 points making up our quad. We have this line, we have this line, we have this line, we have this line, and then we have a point somewhere. Let's take the point here. And then we take this point, let's take it minus the start point. So we get this, 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 this. Then we do the cross product between these. Yeah, I think I understand it if we take the cross product between these, so we get a normal. And then we take the dot product between our plane and normal and whatever normal we create here. Because that means if the point would be here, for instance, we would get some of these. So sometimes the normal would be pointing upwards with the plane. Sometimes it would point downwards, right? Let's try it and see what we get. I think DirectX is hot shit. Yeah, it is. $12 is fucking sick, man. I think, look at this. I love, so what I want to work with is, can we get that link? Let's take a look at what I would love. What I would love to be working with is, let's see if I can find it. Although, yeah, the only reason I'm not working with it is because you exclude a wide range of GPUs. Fucking hell, I would love... Is it this one? I would love this. I would love to work with mesh shaders. So I've talked about it previously. I haven't gone that deep into it, but it's my understanding that mesh shader will replace vector. So you have mesh shader and amplification shader, or amplification shader, and they will replace vector shader, tessellation shaders, and geometry shaders. And you will basically work with it like, so it's basically a shader that works like a computation shader, but you're able to return primitives like triangles and stuff like that. And it's fucking sick. Okay, I mean, nah, hot shit is usually referred to as something that is good. Maybe not. Okay, but my use of it was positive. I love this. Would love to deep dive into this, learn everything about it. But I think you need, I guess, if you use it, I think GPUs, if we take NVIDIA GPUs, I think GPUs with a, what is it, Pascal, with the architecture that is lower than the 20 series, you're gonna get it might not work for them, or you're gonna get some abstraction of this shit, so it's gonna be slower. But yeah, this is beautiful. Love it. Like, if we were able to work with mesh shaders instead of geometry shaders and tessellation shaders, all of this we're doing right now would be fixed. I'm gonna Google if Vulkan has C# bindings. I would be surprised if it doesn't. Would definitely be surprised. Okay. So what we want to do now is, if sine of dot of normal and cross between edges 0 dot direction and edges 0 dot start, plane P minus this one. So we create a vector from plane P to the start of the line. We do cross product with the line direction, and then we do dot with the normal, and then we take the sine of it. If these signs we're gonna have to do it like this. Float sine edge 0. if sine edge 0 is equal to this one and edge 0 equal to this one and sine edge. Fuck, is that true? Now we can do it like this. If this one is equal to 1 and this one is equal to 1 and this one is equal to 1 and this one is equal to 1. If that's true, return plane P, because then our projected point is within 1, 2, 3. Something like that. Let's try it. Let's see what we have. Edges. Okay. It actually... we get something at least. Right now we get... we don't get any drawings for this one, but we do for all the other ones. So something is correct. We exit early, but the point we exit with is wrong. Lingling seems there are some bindings, yeah. Oh, that's nice. I would probably choose C#, but I'm a little bit biased. It's pretty much the only thing I've been working in for the last 5 years or something. Okay, so what happens here? Why don't we get a point at all for this one? We return plane P. So what up? Which means that we should return the projected point. It's weird that we just return, that we don't draw anything for this one then. I just want to try and see what happens if we do edges, 0, start. Can we get this? Thinking I googled Rust and got anime as a recommendation. Might be a correlation. Might be. So what this tells me is that our projected P is not what I think it is. What the hell? Turn plane P. All of them. We don't draw any of them. I want terrain tessellation test. Let's do distance, input P, and camera, world space camera position. Okay. Yeah. Take this one, but we replace point P with it. Really? Input position VS, and then we'll replace this one with it. Okay, so this is pretty much the result I want. Right? When we do input P here. Anything. Okay, I find this weird. We properly identify that the point is within the quad, because otherwise we render this. But the point we return is not located where I think it should be. It would probably be best to learn Vulkan in the language I'm most comfortable with, honestly. Yeah, I agree. Like, if it's Vulkan you want to learn, then you should like make it so that you don't have any other distractions apart from Vulkan stuff. And that's usually by working in the language you're most comfortable in. I agree 100%. This is weird. We project it here, everything else gives the correct result, apart from... What the hell? Yeah, unroll just tells the compiler to unroll this for loop, pretty much. I think we've had the documentation up previously here. Unroll HLSL. Here you have it straight from the docs. Then I want to do return plain P. So we always return plain P. And then I want to do I want to do this, and we're gonna make this one bigger. Addition vs plain P. Where do we have our plain P? Are you kidding me? Oh. Okay. Ah. Here we have our point. It's projected on the plane that the quad makes up. But it's projected onto the plane that the quad makes up. But it's still above it. Is this projection not correct? Maybe I should have stated 3D. Oh, thank you. ABC is normal. Define vectors AB and AC. Calculate the vector from point to plane. ABAC. Projection vector. Yeah, so then we do AP. And normal we already have. AP is just P to A. P minus A. That's what we do here. Dot divided by dot time. Oh. We don't want to multiply here. Is our normal wrong? No, multiply. Are we talking multiplication here as well? Okay, so here we want dot product. And here we want multiplication. So just like we had it. Would love to get this done today, but let's see. So the projection should be like this, and then projection vector, and then we do p minus projection vector. Doing AP, so P point A. P minus quad P1 dot divided by dot times normal. What normals do I send in? It's the correct one. Oh, it might be this one. It screws it up. Maybe. So let's take a look at what we're actually doing here. Fuck it, I don't care. I don't want to branch here. We're pretty much just going to... I think we're just gonna project it at all times. Hey, what's up, Nikki? Thank you for the raid. Appreciate it. Hope you had a wonderful stream. Okay, so we project... We always project point P down. That should work. Okay, and then if we add back this. Okay, beautiful. Stream was pretty good, nice. Got a lot done for UI work. Beautiful. I'm gonna dive into UI work myself soon. Actually looking forward to it. I'm pretty happy with how it's coming along. Nice. Over on this channel, over on this stream for the last weeks, we've been fighting with Tessellation. But I'm pretty sure we are right at the end of it currently. just have a few tiny bits to get in place. Okay, so what we have done today, unfortunately you're coming with the raid just as I was about to round off, so we're gonna send it onwards somewhere else, although I do appreciate it. But like, so what we have done today is we have our initial mesh, which consists of a set of sub-quads. All of these sub-quads are going to be tessellated individually. They are going to be tessellated based on distance to camera. We have a few constraints set though. 2 neighboring sub-quads, and I'm talking about neighboring in the Y or X direction, not diagonal. They cannot be tessellated, like the tessellation constant difference between them can't be bigger than 1 or 2 to the power of 1. So it's very important that when we tessellate these sub-quads that we keep that constraint in place. And we do that, we're gonna do that by basing the tessellation constant on the distance from the closest point on the subquad to the camera. And then we are gonna define a set of radius steps. I think this might work. Double it and pass it on to the next raid. Hell yeah. So tomorrow, so all the groundwork we have done today, tomorrow we're gonna apply it, and we're gonna apply it by the first sketch, this one. So we're gonna take the camera position in the center here, and then we're gonna walk along the line, and we're gonna walk 1 diagonal in step. The ones that are inside the first iteration are going to be tessellated by 2 to the power of x. The ones inside the green ones are going to be tessellated by 2 to the power of x as well, but we're going to interpolate the newest points here, the height of the newest points, so we get a fading effect. For this one we have tessellate by 2 to the power of x minus 1. Same for this one, but here we interpolate as well. And then as we move outwards, we tessellate less and less and less. But the interpolation, so the interpolation constant will be, for the green one, it will be between 1 and 0. For the blue one, it will be 1, 0. For whatever is outside of this one, it will be 1, 0. And I'm pretty sure this will work even with our seams that we have here. Yeah, it's going to be very interesting tomorrow, but unfortunately I have to run. Yeah, hopefully, like I really hope that we can close off Tessellation this week and be done with it. Yeah. Okay, thank you so much for watching, everybody. Thank you for the raid once again, Nikki. Appreciate it. And have a great rest of the day. Peace.